Hi guys, I'm Pradeep. Today I'm going to teach you how to use Laplace equation and Poisson equation. Firstly, let me explain what is Poisson equation and Laplace equation. Here, first let me write down here divergence of E equal rho divided by epsilon naught. This is the differential form of Gaussian's law. Then, as we know, electric field equal minus grad V. Okay. Then we can substitute this E to here. Let me write down grad equal minus grad V equal or divided by epsilon. Then we have grad square V equal or divided by epsilon naught. Okay. Finally we have grad square V equal minus rho divided by epsilon naught. This equation known as Poisson equation. Now then, if region is free of charge, that means rho equal 0. Then we have grad square V equal 0. This equation known as Laplace equation. Okay, this is the main thing we should know. When we are dealing with Laplace equation or Poisson equation, you want to know how to use this Laplace equation on three coordinate system. That means Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. Let me write down this formula first. For Cartesian coordinate system, that is square V equal then this is equal to 0. This is the Laplace equation for Cartesian coordinate system. Then now let me write down Laplace equation to spherical and cylindrical coordinate system. First I will write down it to spherical coordinate system. That is square V equal 1 over R square double R square double V over double R plus 1 over R square sin theta double theta sin theta times W over double theta plus 1 over R square sin square theta double square V over double 5 square equal 0. Okay. Then for cylindrical coordinate system, that is square V equal 1 over R double R double V over double R plus 1 over R square 1 over R square times W square V over double 5 square plus W square V over double Z square. This should be equal to 0. Okay. These are the Laplacian equation for three coordinate system. This is for Cartesian, this is for spherical and this is for cylindrical coordinate system. But you don't worry about this formula. You don't want to remember this formula. They will give all of these formula in the exam. Okay. You don't want to remember these things. Okay. Now let me explain couple of problems. Okay. This is the first example. I consider here two spherical cells. two conducting spherical sheets. First one has R1 radius and second one has R2 radius. Let me write down what is R1 and R2. R1 equal 0.2 meter and R2 equal 0.7 meter. Okay. Now let me write the Laplacian equation for spherical coordinate system. Why is that? This is spherical cell. So we need to use spherical coordinate system here. That is going to be equal 1 over R square double over double R square double V over double R plus 1 over R square sin theta double over double theta sin theta times double V over double theta plus 1 over R square sin square theta double square V over double 5 square should be equal to 0. But here important factor is this, because this potential is depend on only R. You get it? Potential here, potential is depend on only R. So we can neglect these two terms. Okay? Potential is depend on simple R, that means radius, so we can neglect those kind of things. Then we have that square equal 1 over R square double over double R square times double V over double R should be equal to 0. This is the reduced Laplace equation for these two spherical cells. Okay, let me simplify this equation. When I multiply both sides by R square, then I have double over double R square double V over double R should be equal to 0. Then if I integrate once from x to R, I will get R square W double R equal A. That implies W over double R equal A over R square. Now let me integrate another time with respect to simple R. Again, let me write down first. So I will have here V equal minus A over R plus B. Okay, do you get it? The integration mark. Here A and B are constant. We need to find out this A and B. Okay, let me do this. What are the boundary condition here? Boundary condition. When R equal 0.2 meter, we have V equal minus 30. And this is equation number, let's say number 1. When R equal 0.7 meter, V equal 70. V equal minus A over R plus B. This is reduced Laplacian equation which we got first. Okay, using A and 2, that is V equals 70. 70 equal minus A over 0.7 meter plus B. As A equation. Then using A and 1, it is minus 30 equal minus A over 0.2 plus B. Okay. Now I subtract, sorry, this is simple B. Now I subtract A from B. B minus A equal, sorry, A minus B. A minus B. It will give us 70 plus 30 equal minus A over 0.7 plus B. Minus minus become plus A over 0.2 minus B. Here B cancel. Then let me write down here. 100 equal A times 1 over 0.2 minus 1 over 0.7. Okay. Let me simplify this. A equal 100 times 0.2 times 0.7 means 0.14. Okay. Then 0.7 minus 0.2 means 0.5. Then 100 multiplied by 0.14 means 14. 14 divided by 0.5 means 28. Okay. Do you get it? Okay. Substitute A value from equation A using equation A. Set equal minus 28 divided by 0.7 plus D. Okay. 0.71 and 40. Yeah, it is 40. Then we become 70 plus 40 equal to 110. Then we have V equal minus A means 28 divided by R plus 110. This is the V. Okay, do you get it? Now let me find out simple in image electric field. I will erase those things. As you know, electric field equal minus grad V. This is not gradient, this is not divergent, this is gradient. Okay. We are using spherical coordinate system. So let me write down how to derive electric field using spherical coordinate system. Is grad V equal WV over WR AR plus 1 over R W over W theta A theta plus 1 over R sin theta W over W phi A phi direction. These are directions. But you don't want to worry about this formula. Surely they will give this. Okay. Look at this. V is only depend on R. Also, E is only depend on R only. So, we can neglect these three. Okay. Then, grad V equal W over WR AR. Using this equation, equal minus W over WR. Direction is R direction. Okay, let me simplify this. Minus W over WR. It become minus 28 over R plus 110 AR. Okay, this is constant. If we get derivative with respect to R, it will be 0. And says minus minus become plus, then W over WR times 28 over R. Okay, that means minus 28 over R is square AR. Okay, this is E component of this V. Okay, this is V value and this is E value, potential and electric field. Now let me find out capital D. How can I find out it? As you know, D equal epsilon naught times E. Then just substitute in E to here. I can reduce this D as minus 28 epsilon naught divided by R square A R. Okay. This is the first example. Okay, let me explain second example. Here, two cylindrical cell. Small one has radius A, biggest one has radius B, and outer surface is rounded. That means V equals 0, and inner surface has V naught potential. Okay. So I need to use here cylindrical coordinate system for Laplace equation because we are considered two cylindrical cells. Let me write down Laplace equation for cylindrical coordinate system. Let square be equal 1 over R double over double R double V over double R plus 1 over R square double square V over double 5 square plus double square V over double Z square should be equal to 0. Look at here. In here also potential is depend on only R. Potential is only depend on only R. So we can neglect phi terms and Z term. Do you get it? Potential is depend only R. So I neglect these two. Then 1 over R double over double R W double R should be equal to 0. If I multiply both sides by R, then I will have here. Let me integrate with reference to R here. Then I will have R over W over W R should be equal to A. Before integrate, let me solve this W over W R should be equal to A over R. Okay. Okay, let me integrate this equation once with reference to R. Then A over R. Then I have here V equal A ln R plus B. Okay, V ln R plus B. This is same as number 1. Okay, now let me solve this problem using boundary condition. What are the boundary condition here? When R equal A, V equal B, no. This is named as number 2. When R equals simple V, V equals 0. This is named as number 3. Using number 1 and number 3. Okay, using number 1 and number 3. I will have here then V equals 0 and A ln V times V. Okay, using this we can write down V equal minus A ln V. Okay, by substituting B into equation, no, let me use boundary condition 2 and equation 1. Using equation 2 and equation 1 and 2. Equation 1 and 2. Then V naught and A over A times ln A plus V equal V naught equal A ln A time plus B. V naught equal A ln A plus B. Okay. Okay. Now what I am going to do? I am trying to find out B. Okay. Okay. I can substitute this B into here. Let me do this. V naught equal A ln A. Then minus A ln B. Okay. Then A ln A over B. This is not complete answer. I am going to find out A using this. Then I can write A has as V naught divided by ln A over B. Okay. I have found both A and B. So I can write down V as A mean V naught over ln A over B and ln R. Okay. And V as A times ln B. A times ln B. That means A mean V naught ln A over B and times ln B. Okay, let me simplify this. I can get out V of ln A over B. Then ln R over B. Okay, this is our V value. You get it? Okay, now let me find out simply E mean electric field. As we know, E equal minus that V. We are using cylindrical coordinate system. So let me write down what is grad V for cylindrical coordinate system. It is W over W R AR direction plus 1 over R W over W phi A phi direction W over W is AC. As you know, potential is depend on only R. R means radius. So we can neglect these two because this is depend on phi coordinate and this is also depend on Z coordinate. So I neglect these two. Okay. Now let me simplify this. E equal minus that we mean minus W over W R V equal V naught times ln A over B times ln R over P. Direction is A R. Okay. So let me simplify this. W over W R V naught ln A over B ln R minus ln B. This right? Yeah, this right. Then V naught ln A over B times this should be minus ln R minus ln B A R. Then ln B is not depend on R, so should be 0. When ln R, when we get okay, oh yes, this is not depend on R, so it is 0. Now let me simplify this. V naught over ln A over B. If we get derivative with respect to R, it should be 1 over R. Okay, 1 over R AR. if we multiply this from minus sign, it should be V naught ln, then it will become B over A, not A over B, B over A here. Okay, do you get it? Times 1 over R A R. This is electric field component. I can say it as ER because it is depend on the R. Okay, now let me find out simple D. D equal epsilon naught times simple, sorry, capital E. E mean electric field. So we need to just multiply by epsilon naught this. Then V naught ln B over A time 1 over R time epsilon naught times A R. This is the answer for capital D. I hope you will get better idea about this Laplacian equation and Poisson equation and how to solve this Laplacian equation in coordinate system, how to do this in calculation. So like my videos, share these videos for others, subscribe my channel, join with me, I will do better thing for you. Thank you.